I'm Anil Kumar, and let us review what we've learned about polynomials in factored form. The question here is sketch graph of a cubic function with given zeros. Then write the equation of the function. Right. So first we need to sketch, then write the equation. Okay. So let's begin with the very first one, which says, we'll just sketch first. Okay. So it says that it has two zeros, right, with given zeros. So we are given zeros. So these are zeros for us. First one is at -2. Let's say this is at -2. The other one is at 3. Let's say this is at 3. We know this is linear and that one is cubic. So if it is linear, let us say the graph will cross like a line. Is that okay? So at one place it has to cross like a line. So let's say this place it crosses like a line. And the other one, it says it is of order 2. That means it kind of bounces back as a turning point. So that becomes our zeros. Now we'll connect these points to sketch the graph, correct? So the graph is kind of, let me just extend this and connect this with a smooth curve. So that is how we can go about. That's perfect. And then we can go and extend this and end up like this. So that could be the graph with the given zeros and their multiplicity or order, right? Now we need to write equation. To write equation, let's begin by saying f of x is equal to, first factor is linear, we'll write x plus 2, right? So that is the linear factor. The other one is of order 2, x minus 3, is that 0 of order 2. Now, what should be this value a? That is decided by the y-intercept. But in our case, if I just write f of 0 as, what is this, right? Let me calculate f of 0 here. Then what we get here is, if I substitute 0 here, I get 2 times minus 3 square. 3 square is 9, and 9 times 2 is 18, right? So we get 18. However, it is on the negative side. Do you see that? Since it is negative side, we can say that the leading coefficient should be negative, right? Since it is on the negative side, right? So it cannot be plus 18. Okay. So let me write this as negative 18, and I'm introducing negative here. So this becomes negative, negative. Do you get an idea? So the equation which represents our graph is f of x is minus of x plus 2 times x minus 3 whole square. It makes sense. If you see the end behavior, you notice that right side is down. So the leading coefficient should be negative. You get an idea, right? So that is how it is. Now let's sketch the next graph. So here we are given actually 3 zeros. Okay, we are given 3 zeros here. This time I'll keep right side up, so we'll expect positive leading coefficient. Okay. Now we are given 3 zeros plus minus 2. So let's say this is minus 2 and that is plus 2 for it. And then at plus 4, and let's say this is 4 for us. Okay. Now since these are all linear zeros, our graph is just going to cross them kind of like this. Is that okay? So that is how the graph is. Let me just make them bigger so that zeros are accurately placed. So we do get function, and we can write down this function as f of x equals to x minus 2, that is the first one, and this is at x, I should write plus 2, that's 0, x minus 2, this 0, and x minus 4, the next 0. And let's find what is f of 0 is. It will be 2 times minus 2 times minus 4, that is indeed positive. 4 times 4 is 16. I can write this point as 16. You get an idea. So in that case, my function is x plus 2 times x minus 2 times x minus 4. So that is how we can actually write down the equation from the graph also. I hope the concepts have come together and you have understood the whole concept. Okay, it's important to note that we can actually be very specific. Zeros will give us family of graphs. So this actually gives family of graph. But when I introduced y-intercept, then we specifically give equation of the graph. That is understand. So this is unique. This is unique. So that is why we made our graphs unique by introducing the y-intercepts. I hope this concept is clear. Thank you and all the best.